Did you ever wonder how you can add your own API to the Minecraft system? Something like Fluid API maybe? From this point forward in our glibs system, I want to add my own library and API to handle any sort of solution or slurry or suspension or emulsion physical system as an API to our library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Up until now, I had added two different APIs behind the scene, one of them being the gas API, one of them being the heat API. The base infrastructure was done by Turti, and honestly, it was not a big deal. It was more like a copy-paste from Energy API and Fluid API. However, right now, I want to add a new API of my own to the system, and I thought that, you know what, it's fun to do it in front of the camera. You will see something that you didn't see before. I have Ollama installed, and I have Qwen 2.5 Coder 32 billion parameters as a model. Normally, I don't trust AI to write the whole code for me. I had seen Turti doing it using Codex or Copilot, but I'm against it. In my opinion, it's better to do your own code. And then if you are having a problem, ask the AI and see its guideline and again, implement your code yourself, or at the very least, sit back and read everything that AI is giving you before copy pasting. I thought that it's fun to have this Ollama Qwen available to us on the video so that you can see what is happening every now and then. However, rest assured, I will not do exactly what it is saying, and we will take a look at that in a few minutes. Now, to begin with, I had this question that I want to have different sort of APIs, one for emulsion or suspension or solutions or anything else. Basically, all of these are physical forms that something is being carried by something else. The more I thought about it, the more I found that most of the time I'm doing the same repetitive thing. Maybe at some point I make the decision that an item stack should be carried by water, for example, or in another situation I want this fluid to be carried by water. Between emulsion and suspension and solution, yes, the physical terms are different, the physical forms are different, but when it comes to Minecraft and coding, it really doesn't matter. Most of the time, we want to transfer two or three things with each other from one container to another container, maybe directly or using pipes. And most of the time, we will use them in recipes and crafting. When you think about that, you will understand that we may not need different APIs. So one single API should be sufficient for all of them. Because of that, I went ahead and asked Ollama, Qwen, about a physical term that will handle all of these situations. So I said, I want to code an API for modding Minecraft. This API is about slurry, solution, suspension, emulsion, or any other physical form that can carry something within something else. If you want to suggest a single physical term for this, what do you suggest? Now, normally Qwen 2.5 Coder is dedicated for coding and is trained for coding. However, as you see, the response is really talkative and good in English terms and chat-wise. So he said that a fitting term for this is dispersion. A dispersion is a mixture in which one substance, the solute, is dispersed throughout another substance, the solvent. This term encompasses various types of mixtures, including solution, suspension, emulsion, and more. Then I asked about that more word there, and it's colloid. So he defines different types, and then he says, if you want to implement this, I suggest that you should have a dispersion type, a property system, a component system, a way to interact between different storages, and finally a way to visualize things in the world. Then I asked if I can give him an access to a hard drive folder or a file and he can handle things there. He said, no, just copy paste the code to me. And then I asked about that more keyword and he said it's colloid. Basically a solution and a suspension, emulsion, and colloid is defined in physical terms. Here you can pause the video and read it. But all in all, they are two or three different things that are being carried with each other. Then I asked him if he wants to implement the API himself, what is his suggestion? Keep in mind, at this point, I'm not asking him to write any code for me. I just want to have some idea about where to begin with. And he says that first, we define the structure of the API. We want a solution, a suspension, emulsion, and colloid types. Then we want properties as viscosity, density, concentration, or stability. Well, I'm not sure if I want to add any of them or not yet. Then for components, we have the solute and solvent. Then we have the interaction ability to dissolute rates and particle size distribution or reactivity, and then visualization for 2D and 3D rendering and animations. Now, let's sit back and think about this before start coding, because believe it or not, the thought process, the brainstorming phase for defining an API is really important. If I want to implement anything, do I want to have these properties defined beforehand? I mean, viscosity, density. Okay, what is the usage for them? Viscosity may change the speed of transfer from one pipe to another pipe. Yes. Then density, mass per unit volume, that is for solutions, suspensions, emulsions. Yes, I can see how it can be used. Or concentration. Then stability, ability to remain the mixture over time. Okay, this is an interesting concept. If you want to implement it, then the user of the API will have the ability to destabilize his mixture and, I don't know, maybe craft something or maybe evaporate something to put it inside the base infrastructure. I'm not sure, we will see. For solute and solvent, well, one way or another we have to handle these. Now, interaction, I don't see any use case for these because honestly, when you are dealing with Minecraft API, you are thinking about generating something and then using it in another way or another form. Basically, two different crafting recipes. One recipe for crafting the solution or dispersion, and then another way for using that dispersion and crafting something else. And at the end, a way to transfer this dispersion between 2 points in the world. So interaction basically is transferring API, nothing beyond that. The visualization is a totally different thing. It's just rendering the dispersion in the UI and then in the world. Well, we had a renderer for fluids in the world. However, in this scenario, we have to use another helper to render things in the world in a different way. But now, it is a bit more complex because as the chat suggests later, we may want to render some particles or some items inside the solution or the dispersion. I don't know. It's up to the user. In my opinion, this part, the animation part, is up to the user because at the end, it is a block entity renderer, and they should handle their own block entity rendering in the world themselves. I'm not gonna add anything related to particles or items being rendered. However, regarding the fluid-like rendering, I will give a helper method. Basically, it's a duplication of the previous one that we had, or I will change that one in such a way that instead of water or, I don't know, a fluid variant, it accepts any sort of variant. We will see that later. Now he starts with setting up a Fabric API and a mod, and then he starts coding. However, I'm not gonna use its code as a beginning stepstone because it's not robust enough. Using what Turtiworthy had as a base for heat and then gas and his slurry API gave me an idea of what we need to have as a base before moving into dedicated aspect of an API. Basically, what you need as the very base is the substance itself. For example, a dispersion or a slurry or heat or gas or whatever. That entity, that thing in the world that you want to add as an API needs to have an entry point in the code as a record. And it needs to have an ID because you want to have your own dissected registry system inside Minecraft's registry heart so that you can register things into the registry system under a new key so that you won't be dependent on Fluid API for fluid keys or I don't know, any other predefined keys as the entry keys in the registry system. Because of that, we need to start somewhere, and the best place to start is a record. So inside API dispersion, I will add a package and I will call it base. And inside here, I will add a new class. This is a record and I will call it dispersion. Now, normally for the records, I will have a package and I will have that, but this is the heart of everything related to Dispersion API. I don't want to put it under records, at least not yet. I may change the places of things around the API later. However, for time being, we want to make sure that things work. Normally, you need an ID here, and that would be the only thing that you add to a dispersion. Then you want a Boolean that says it's matching the type. So matching type. And here we want to give it a dispersion in, and we call it dispersion. All we want to do is to return if the dispersion that we gave in equals to this. So it's the same dispersion or not. We are not comparing the ID. We are not doing anything like that. Believe it or not, this is all we have to do for the base dispersion class, okay? The next thing we want is a variant. Just like fluid variant, we will have a dispersion variant. However, from this point forward, we will go back and forth between different classes. Because of that, I prefer to add those classes into the whole structure of the files and then move on and talk about the contents. So one of them, as we said, is an interface that we call dispersion variant. Now, before doing anything else, I will say it's extending the transfer variant of type dispersion. I'm not going to add anything to the class yet because we want to have an implementation of this class later. Remember, it's an interface, and basically an interface is not a finished code. So we want a class that says dispersion variant IMPL as implementation. Now this one implements the dispersion variant. And yes, it is telling me that I need to implement some methods, but as I said, I'm not gonna do that yet because we still have things to handle and do later down the road. We will come back here and fix the problems here. Under the API, directly under the dispersion outside of the base or anything else, I will have a Java class and I will call it Dispersion API. This is the main entry class that we will have everything sitting here. If I want to follow my own steps as folder structures, you see that outside of the base, I have this storage, BE, block, interface, and utils. So I just gonna mimic the whole structure here. So we will have a BE, we will have a package for block, we will have a package for interfaces, we will have a package for storage, and finally a package for utils. Now, under the client, I think for gas, I have some things here. So let's go here and take a look. You have interfaces and then the render handling and things like that. Let's go and add a package for interfaces maybe, and the rest will happen later. Now that we have this infrastructure, we can sit back and talk about what is happening and what's going on here. The variant, as it says, it's a transfer variant. Now, this is something that Transfer API use a lot. Basically, this is how Transfer API knows what thing should go in or should come out. And this is the implementation of this interface. So this is the heart of everything. Honestly, I may start with the implementation. I'm not sure. We will see. But the Dispersion API is just like your mod initializer. It will initialize some things. It will create the registry system and everything like that. If I want to start, actually, I can start with the API, I think. If I want to compare it to the gas again, you see that gas API has these components and then a register helper, and finally it has this init that registers to data components. However, you may ask yourself, wait a minute, shouldn't this happen inside mod initializer? Then why don't we see gas API follow the mod initializer. The thing is that under FMJ, you don't see it right now. We can have an entry point right after environment that accesses this init method inside our API and calls that init method there and behaves like an initializer for a mod outside of any library. However, that is something that we will talk about it later. Right now, I want to write this dispersion API and start things rolling. So we will say public static. This should be final. We call it registry key. Well, we don't have it. I forgot. We have resource key. Yeah, I'm still dedicated to yarn in my brain. Resource key of registry type of dispersion. Okay, this is a registry key that we are defining here, and we call it dispersion underline registry underline key equals to, and we call it resource key dot. As you see, we have this create here, and we have the one that accepts identifier. I want the one that accepts identifier, create a registry key from an ID. Now the ID is an identifier, so we have the base helper dot ID. Now, as you know, the base helper ID uses two things. One is the mod ID and then the key for the identifier. For mod ID, I will go with Dispersion API, or I think I will use the underline and API like that. Then for the key here, I will say dispersions as plural, okay? However, I may want to use this mod ID outside of this identifier here, so I will cut it here, and I will say that it's mod underline ID or mod ID, I don't know. Then I want to create that, so I will say, now we say public static final string mod ID equals to that. Now that we have these two, I can finally add our registry entry to the heart of Minecraft. So we say public static, and this is again final defaulted registry of dispersion, and we call it dispersions equals to fabric registry builder. This is from Fabric, but it builds a registry entry, but basically a registry dictionary that create, but we have the create defaulted. We want create defaulted, the dispersion registry key. This is our key in the whole system. And then here we want an identifier. We say base helper dot ID of the mod ID. And then for the key, we can say empty. I don't like this empty word here. By the way, I have my notes so that I can follow them. I will use dispersion. So outside of the second parenthesis, I will say dot attribute. So we want to add an attribute, and that is registry attribute dot modded, and then another attribute, and that is registry attribute dot synced, and finally we call build and register. This will become our entry inside Minecraft as a whole registry system, or category, I should say. After this, we want to utilize this registry to register an empty entry into our system. So we say public static, this is final, and this is a dispersion. We call it empty equals to, we call a method that we will create a few minutes later, and we call it empty. So this will be an empty dispersion into our system. Basically, the way we use it is just like saying that, hey, fluids.empty or gas.empty. It's an empty entity inside the whole system. It's a type of dispersion, but it has nothing in it. Now we want this register method, so we say public static that returns a dispersion, and we call it register. This register will accept a string ID, return, we call another overload of ourselves that creates a base helper.id using the mod ID that we have and the ID that we sent in. Of course, we don't have this overload right now, so we say public static that returns a dispersion register that accepts an identifier, and we call it ID. So here we say return registry.register. We want our category, that would be dispersions this time. with the ID that we sent in a new dispersion. Here we want the ID as the string, so we say id.toString. This way we added our own dispersion into our system, and this is an implementation example, by the way. So we already registered an empty dispersion into our registry system using one of these two calls, and you can use each one of them. And because we have these registers on the API structure, we don't need to have it under the registry or register handler library that I provide. Basically, we have the helpers in place so that we don't need to look around. That is our Dispersion API for time being. Later, we will come back and maybe add things here and there. For example, we don't have an init method. We want that public void init here, and this will be public static void. Our entry inside the initializer as any initialization. Actually, I think it should be void. And here, if we need to add any components or anything else, we can register them later. However, for this video, I think it's enough because we have in our dispersion, we didn't do anything regarding our variants. However, we started implementing our API entry point. We defined our registry type inside the registry system and our key, and we already registered an empty dispersion. In the next video, we will start working on our variant. Have fun, everyone. Bye.